In the periodic table, let's look at the other two unique groups in nonmetals. We're going to take a look at both the group 7 elements known as halogens, and group 0 elements known as the noble gases. Halogens are fluorine, chlorine, bromine, iodine and astatine. They also change from gas state to solid state down the group. Halogens have colors and become darker down the group. They are poisonous and smelly. Fluorine is a very pale green gas. Chlorine is a greenish-yellow gas. Bromine is a reddish-brown liquid. Iodine is a gray solid that sublimes to a purple vapor. Astatine is a black solid and radioactive. Moving down the group, the reactivity of the halogens decreases. All of the halogens can exist as pairs of atoms, that we call diatomic molecules, which means two atom molecules. For example, fluorine and chlorine. Also, they have 7 electrons at their outermost shell, therefore, they are reactive, as they only need to get one more electron to be stable. However, as mentioned earlier on, there are more electron shells down the group. The distance between the protons and electrons is getting further apart. The force of protons attracting electrons from other atoms is weaker. Hence the reactivity of halogens decreases down the group. Moving down the group, atomic radius increases by 1 electron shell. As a consequence, melting points and boiling points and their density also increase. The next thing we need to look at is how halogens form ionic bonds with metals. When a halogen gains an electron to form a 1- ion, we call it a halide, and we have to change the name slightly, changing the ends to these. So we get fluoride, chloride, bromide and iodide. You'll probably most often see halogens forming ionic compounds with the alkali metals in group 1, when chlorine gains 1 electron from sodium to form sodium chloride, as we have here. We will learn about the halogens and their key reactions, the displacement reactions. A more reactive halogen will always displace a less reactive halogen in a compound. We will demonstrate these displacement reactions using aqueous solutions of chlorine, bromine and iodine. Substitution of halogen compound. The test tube contains a pale green aqueous chlorine solution. After adding sodium bromide, the aqueous chlorine solution changes from pale green to brown. As the aqueous chlorine solution contains chlorine, and the reactivity of chlorine is higher than bromine, the bromine ions in the aqueous chlorine solution are displaced by chlorine, and produces bromine gas. Bromine dissolves in water, and turns into an aqueous bromine solution. Then the aqueous bromine solution is added with potassium iodide. The aqueous bromine solution changes from brown to dark brown. As bromine is more reactive than iodine, it displaces iodine from potassium iodide. Iodine is dark brown and becomes an aqueous solution of iodine. Therefore, the order of reactivity of the halogen elements is obtained. The chlorine is more reactive than the bromine, and the bromine element is more reactive than the iodine. The chlorine solution is pale green, the bromine solution is brown, and the iodine solution is dark brown. Halogens have similar chemical property. We will demonstrate these reactions using aqueous solutions of chlorine, bromine and iodine. On adding sodium sulfite, aqueous solutions of chlorine, bromine and iodine all turn colorless. Thus chlorine, bromine and iodine behave similarly. Let's look at group 0, noble gas. Noble gases appear as colorless gases at room temperature and pressure, hence they are inert or unreactive. Noble gases are monoatomic elements, which refers to molecules composed of just one atom. They all have full outermost electron shells. Helium is very light and does not burn. It is used to fill balloons and airships. Neon is used in advertising signs. Argon does not react with metals. It is thus used to fill electric light bulbs. If you enjoyed it, then please do share it with your friends, and we'll see you next time.